Hey, welcome back to Mrs. Cooley Teaches. I don't know, we need almost like a segment name for this. All right, so first and foremost, I would love to be doing these lessons in class and teaching you guys, but this is kind of that best alternative so that way we can maximize the time that we have together. So I know taking notes at home can kind of be a burden sometimes, but I thank you really for everything that you're doing and making sure that you're staying up to date with what we're doing. So in this video, we are going to be moving on to our next shape, the volume of cones. Okay, so I'm nervous. I have some water here. So we were talking about cylinders, circle on each side, okay, wrapped with a rectangle. And we're now moving on to a cone. So again, we have that same circular shape, except this time we come to a point. So I'm nervous, like I said. So I took this cone, and I don't know how well you can see it, but he is filled with water. There is an air bubble in there. And I have this cylinder. Again, same height, same shape. And I filled it with water, and I'm now going to dump it into this cylinder. How much water do you think is going to fill? Do you think it's going to fill all the way up? Do you think it's going to be halfway filled? Is it going to go 3/4? How far do you think this water, when I dump it in here, is going to fill up? All right, let's try. So I'm really nervous because I'm going to probably spill water all over myself, but that is the joy of teaching, right? So we're going to take off the little lid. All right, I'm going to see if I can match these up exactly. I'm nervous, guys. All right, so we got it filling. Take a look at that. Can you see it? So all of the water just dumped out of the cone. Maybe a little bit water left. Okay. Check that out. How much do you think that's full? Okay. Now, if you look at it, if I take my fingers, because it's the official measurement when it's your fingers, and I put it up a little bit and then up a little bit. Did you know that this cone of the same height and the same radius fills 1/3 of a cylinder? Well, that information is going to help us out when it comes to finding the volume of cones. All right, I made my desk all wet. All right, so let's take a look. So first and foremost, we need to know about a cone. A cone has a base that is a circle, but the other side comes to a point. So when you draw this, you're going to draw your little oval, you're going to draw a dot, and we're going to draw a line that connects on a little triangle there. All right, so we're going to go ahead and we're going to write our formula with this. So I'm going to go ahead and I'm going to put a little marker here because we also have to measure that part. All right, so we're going to write that a volume of a cone equals pi radius squared, which is my circle, times height, because that is the distance. So notice that's the formula for a cylinder. Okay, so that is a cylinder. But remember, a cone only fills 1/3 of that cylinder. So 1/3 actually jumps in front of this. So the formula for a volume of a cone is 1/3 of a cylinder, pi radius squared times height. Right? Easy enough, right? So we're going to do exactly the same thing we did with cylinder, except we're either going to multiply it by 1/3 or we can divide by 3 because that fraction bar means division. So you could also interpret this as pi radius squared times height all divided by 3 because we're taking that cylinder and we're chunking it into 3 different spaces. All right, so let's actually practice this skill then. So example 1, we have written here, this is our first example. All right, so you notice that we have this little piece here that is 3, and we have the dotted line, which is my height, which is 6 inches. So I would encourage you to draw it so you can kind of see the different pieces and parts of it. So again, I have 3 inches and I have 6 inches. So that 3 inches, is that the radius or is that the diameter? Right, that is the radius. So I can go ahead underneath this and I can put R equals 3 because the radius is 3 because I need radius in my formula. Right, and the height is 6. So that is the amount that this is moving up there. So we're just going to take our formula and we're going to fill it in. So we're going to say volume equals 1/3. All right. pi, radius is 3, height is 6. What mistake did I just make? I did forget to square it. That is probably the most common mistake that I find. You must square the radius. Radius squared times height, then do the rest of what you need to do with it. All right, so we're going to grab our handy dandy calculator. All right, notice I didn't put 3.14. It didn't tell me. So I'm going to write this in terms of pi to start. Okay, so I'm going to do in my calculator, I'm going to do 3 squared, so 3 squared times 6, because you know what? I can see that real easy. And I'm going to push enter. So I get 1/3 pi 54. Now in my calculator, I can do 1/3. I would type in 1. I would type in this ABC fraction button, and then I would type in third. Then times 54 equals 18. So the volume of this would be 18 pi. So again, I did 3 squared times 6 times 1/3, and I got 18 pi. Now I could type in my calculator 3 squared times 6, and then I can divide that by 3 because remember, multiplying, and I'm still going to get that same 18. Now if they then said use 3.14, well, that's what I'm then going to do. And I'm going to do 18 times 3.14 equals, and I get volume equals 56.52. And then I would steal my label, inches cubed. Okay, so same exact thing with cylinder, only we're dividing it by 3. Pi radius squared times height divided by 3. All right, let's try another one together. All right, so here I have a radius of 2 and a height of 8. Radius of 2 and a height of 8. So we're going to start again with our formula. Volume equals 1/3 pi radius squared times height. And now we're going to fill it in. Volume equals 1/3 pi. Radius is 2, and we're going to square it. And the height is 8. And now I'm going to plug it all in my calculator except for pi. I'm going to leave pi alone. So I'm going to type in 1 ABC3 for 1/3 times 2 squared, because that's what I wrote, times 8. So 1 ABC3 times 2 squared times 8. And I get 10 and 2/3. And notice my calculator spoke to me, right? So I get volume equals 10 and 2/3 pi. And then again, depending on what pi they tell me, 3.14 or the pi button, I know what I'm going to do from there then. And then we're going to label it inches cubed. So again, volume is 3-dimensional. All right, so it's time for you to try. All right, I have 2 you-dos for you, maybe. There they are. All right, so you're going to go ahead and you're going to answer these 2 questions. We're going to see how you do. So let's say, we're going to say in terms of pi. All right, so go ahead and try these out and let's see what you get. All right, so let's check it out. Let's see if we filled in our formula the way we needed to. So we should have had pi radius squared height, and we have 1/3 of it. So we should have 1/3 pi 14 squared times 13. Ooh, these are going to be some really big numbers, I think. All right, so we're going to get our calculator out. So let's check it out. So 1 ABC3 times 14 squared times 13 equals, our volume should have equaled 849 and 1/3 pi. That's big. But that might be a really big swimming pool that's in a cone shape. Ooh, or a really big ice cream cone. Or a giant party hat, right? Any of those would be so much fun. All right, let's take a look at number 2. 1/3 pi radius squared times height. So we're going to fill it in, 1/3 pi. My radius would have been 6. Did you do the radius correctly? So I should do 6 squared times 28. All right, so let's check out in our calculator. 1 ABC3 times 6 squared times 28, and we get 336 pi. All right, so hopefully this video helped you out finding the answers to the volume of cones. All right, and if you have any questions, make sure you let me know.